Hello everyone. I welcome you all to Startup Academy, your online gateway to success in ISS exam. This academy is exclusively for ISS only, and we have been covering the third paper in which we started the topic sampling techniques. And in the previous lecture, we discussed about the topic. sorry, we discussed about the topic PPS in which we have found out the expectation of the statistic or the estimator. In today's lecture, we will find the variance and estimation of variance. So, beginning with the term PPSWOR. The estimator we defined in yesterday's class was z bar, which was nothing but z1 plus z2 upon 2. We were discussing Desraj estimator. So, in the of the case where we take two draws. So z1 is draw 1 and z2 is draw 2, and z bar is our Desraj estimator. We can write it as dr estimator. And we in previous class we discussed that estimation of this large estimator was nothing but equal to population mean, and hence we can say that this estimator is an unbiased estimator of population means, which we wanted to prove as well. So I hope till here all the things have been clear. Moving forward with the variance. Variance of Desraj estimator, we only have to remember the variance, the term variance. There is no derivation required according to your syllabus. So we'll be directly writing the variance, and we'll conduct a derivation of estimation of variance. So the variance of Desraj estimation variance can be written as variance of z bar is equals to variance for, we can write the heading variance for the case of two draws in order to be specific. So here variance can be written as 1 minus 1 upon 2 summation I goes from 1 to n pi square in the bracket, and in the other bracket we can write as 1 upon 2n square into summation I goes from 1 to n pi bracket yi upon pi minus, what was it, y total, where y total is the total values of summation of y's, minus 1 upon 4 n square summation I goes from 1 to n pi square bracket yi upon pi minus y total whole square. So this is our formula for variance of the case of two draws in Desraj estimator, which is 1 minus 1 upon 2 summation I goes from 1 to n pi square bracket open 1 upon 2 n square summation I goes from 1 to n pi bracket yi upon pi minus y total whole square bracket close minus 1 upon 4 n square summation I goes from 1 to n pi square yi upon pi minus yt whole square. This whole term is same to this term, but the difference is here. Here it is 4, here it is 2, and here it is pi, and here it is pi square. Rest all the term is same, and here it has been multiplied by this, previously multiplied by this. So this is one term and this is another term, and they are related with a negative sign from in between them, right? So that's how you can learn it. It is the thing that you need to learn by heart, nothing else. I can prove you. Proving is difficult for this one, but it is not in our syllabus, so I'm not doing it in the class. Why do we waste a time on such difficult complex thing when it is not required to? So I am directly moving to estimation of variance. You can again write in the case of two draws. Okay, so we know that variance of z bar, which is Deslav's estimator, can be written as estimation of z bar whole square minus estimation of z bar bracket whole square. This can be written like this, so it can be rewritten as estimation of z bar whole square minus y bar square. Since we know that estimation of z bar, which we have proved in yesterday's class, is nothing but y bar is an unbiased estimator of the population mean, so we can write it like this. So we can take this as equation number 1. Now let us take, since estimation of z1 z2 can be written as, because we have been taking two draws, z1 and z2, so it can be written as estimation of z1 estimation of z2 given first unit has already been drawn. This can be written like this. So it can further be written as estimation of Z1. Now estimation of Z2 when first unit has already been taken out is nothing but unbiased estimator, which is population mean. Now moving on further, we were discussing about estimation of Z1, Z2. This estimation of Z1 Y bar can be written as, Y bar is a constant, it comes out, and we are left with estimation of Z1. So we can write it as Y bar into estimation of Z1 is also Y bar. So it can be written as Y bar whole square. Let this be our equation number 2. So now moving on forward, let us consider estimation of z bar minus z1 z2. We can take it like this, the estimation of z bar square minus z1 z2. So taking in estimation on the bracket, estimation of z bar square minus estimation of z1 z2. Since estimation of z bar square, we have to write it directly like this, and estimation of z1 z2 from this equation number 2, we can write it like y bar square. We can write here from equation number 2, and hence this can be written as estimation of z bar square minus y bar square is equal to variance of z bar. This we can write from equation number 1. You can see on your own, this was equation number 1 and it was nothing but equal to the variance of z bar, right? So that gives you this, and hence we can write that variance of z bar is an unbiased estimator of variance of z bar. So this completes your topic, Desraj estimator and ordered statistic estimator. Now moving forward to the topic of unordered estimators. So what were ordered estimators and what are unordered estimators? Unordered estimator. When we take into the consideration of drawing the samples one by one, we take into the consideration the order. If first one is drawn, then it is first order. Second one is second order. Then those kind of estimators are known as ordered estimator. But when we do not take into consideration the order, either first is selected for one first or second is selected first, we don't consider it. Then this is known as unordered estimators. So we can write it as in ordered estimator, the order in which the units are drawn is considered, while there exists corresponding to any ordered estimator, there exists a unordered estimator which does not depend on the order or in which the units are drawn. I am writing it now. In ordered estimator, the order in which units are drawn are considered. This is all theory, but we have been asked many a times the theories as well, so I'm making you write the theory. Considered. And corresponding to every ordered estimator, there exists an unordered estimator whose order is not considered, taken into consideration, or we can write. So this is the outline of the ordered and unordered. And unordered, we can also write that unordered variance, unordered estimator variance. Suppose we have unordered estimator as ZO. So variance of unordered estimator is always less than equal to variance of ordered estimator. So O represents ordered and U represents unordered. So it is always less than equal to the ordered estimators. So if we talk about, let us take a sample by simple random sampling without replacement from a population of size capital N. So the number of unordered samples would be NCN, and corresponding to every unordered sample there exists an ordered estimator or sample of size small n factorial. All we want to know that the number of unordered sample is NCN and the number of ordered sample is n factorial. We'll do two examples based on this so that it will be more clear to you. Suppose we have to take example 1. Suppose n, which is the number of draws, is 2. So ordered sample is let us take the units as U1 and U2. These two units has to be drawn from the population. So the ordered sample would be first U1 is selected, then U2 is selected. And the second ordered sample would be first U2 is selected, then U1 is selected. So with our formula, it should be n factorial, which is nothing but 2 factorial. 2 factorial is 2 into 1, which is equals to 2. And hence we have got 2 samples. From of unordered, if we do unordered sample. So unordered sample would be U1, comma U2. And it will be equal to 1 only. Right? So we don't know about the population, so we are considering population as 2 only. So if we take population 2 only, then we'll get NCN, which is nothing but equal to 2C2, which is equals to 1. So this is unordered sample. We are not considering the order whether first unit is U1 is taken at first draw or U2 is taken at first draw. So this will be, and we can write that probability of unordered sample which is U1, U2 is equals to probability of ordered sample 1 which is U1, U2 plus probability of ordered sample which is U2 comma U1. So the probability of ordered sample is U is equals to the two separate probabilities, sum of two separate probabilities of ordered sample. So let us take another example, example number 2, in which we consider n is also small n is equal to 3 and units, let us take units this time as U1, U2 and U3. 3 units has to be drawn. So first of all, ordered sample has to be n factorial, which is nothing but 3 factorial, and 3 factorial is 3 into 2 into 1, which is 6. So 6 samples would be drawn in order. First of all, we draw U1, then U2, then U3. Then the second sample would be U1, U3 and U2. The second sample, third would be U3, U1, U2, sorry, U2, U1, U3 and U2, U3, U1. The fourth sample would be U3, U1, U2, and the sixth sample would be U3, U2, U1. Right? So these are the six ordered samples, and unordered sample is one only, because we are not considering order, so it will be one only, and that would be U1, U2, U3. Doesn't matter which one is drawn first, which one is second, and which one is third. So now moving on further, uh, again writing probability of unordered sample. U1, U2, U3 is equals to probability of ordered sample. I'm writing in short form, U1, U2, U3 plus probability of ordered sample U1, U3, U2 plus probability of ordered sample U2, U1, U3 plus probability of ordered sample U2, U3, U1 plus probability of ordered sample U3, U1, U2 plus probability of ordered sample U3, U2, U1. So this is what we meant by ordered sample. And there are two methods. First one is Murthy estimator, and the second one is Horwitz Thompson estimator. This has been rarely asked in the exam, but this one is very important from the exam point of view. So we'll only discuss Horwitz Thompson estimator, which is also known as HT estimator. We'll discuss this in the next class. I hope that whatever we have done today, you have got all of it. And if not, then you can ask in WhatsApp channel or in the comment box. Your doubts will be cleared and relevant doubts will be answered. I hope you are working regularly on your GS and English as well, along with the statistics, and keep on watching the lecture videos regularly. With each lecture, become making you closer to your goal of ISS 2026. So, all the best. Thank you.